PulseBoard's first feed endpoint returns everything the web screen currently displays: author profile, post body, every count, every flag, and internal moderation fields. The mobile team asks for one extra field. The database query grows. An administrator view reuses the endpoint. Soon nobody knows which fields are safe, required, cached, or stable. This is a common system design trap. An API is a contract between independent parts of a system. A data model is an internal representation optimized for storage and integrity. They can be related without being identical. Separating them gives the system room to change. Start with actions, not tables. PulseBoard needs create post, read feed, follow topic, and acknowledge notification. For each action, define the caller, required identity, input validation, successful result, error result, idempotency behavior, and pagination rule. A create post request includes a client-generated idempotency key, so a network retry does not create duplicates. A feed response carries a cursor rather than a page number because new posts can arrive while a person is reading. These small contract choices become visible product behavior. They are worth discussing before code spreads across services. HTTP with a resource-oriented API is a practical default for many product actions because browser and mobile tools understand it well. It does not make every interaction a simple REST resource. A real-time notification stream may use a persistent connection. An internal service may use a typed RPC contract. GraphQL can help when many clients need flexible read shapes, but it also moves query cost controls into the design. The question is not which protocol sounds senior. The question is which boundary needs which capability, how it is authenticated, how failures appear, and how its cost is limited. For PulseBoard, the durable facts are users, posts, follows, reactions, and moderation decisions. A relational database is a strong starting point for these linked records because transactions and constraints protect important relationships. The personalized feed is different. It is a read view assembled from facts. Early on, the system can compute it on demand. Later, it may materialize parts of it or store a fan-out view. This distinction prevents a premature database debate. First, decide which facts must be correct together. Then decide which read shapes need speed, scale, or eventual consistency. In the local contract simulation, one request asks for a post by identifier. The first version trusts the identifier and returns the record. The corrected version verifies that the authenticated member may view that post before reading sensitive fields. A second request retries after a simulated timeout. Without an idempotency key, it creates two posts. With the key, it returns the original result. This is not an exploitation exercise. It is a realistic way to see that API safety, data integrity, and user experience meet at the same boundary. Design the normal path and the retry path together. A useful contract is additive when possible. Add a new optional field before removing an old one. Publish deprecation windows. Measure which clients still use the old behavior. Keep internal database migrations separate from external API changes. When a new feed ranking algorithm needs more data, do not silently alter a field whose meaning clients already assume. Introduce a clear capability or version. The aim is not perfect backward compatibility forever. It is controlled change with evidence, ownership, and a graceful path for users who update more slowly than your servers. PulseBoard now has a deliberately simple rule. Write APIs validate identity, authorization, intent, and idempotency before committing durable facts. Read APIs use cursors, minimum data shapes, and explicit cache rules. Internal services may change their storage implementation as long as they preserve the contract. This choice keeps the next scale step open. In Episode 3, readers outnumber writers by a wide margin, so we add a delivery path that absorbs traffic without pretending cached data is always fresh.